Okay, so this is the sections 7.1, 7.2, and 7.4 quiz review that will be for our geometry quiz on Wednesday. So we'll just go through some problems that are very similar to the ones on your quiz. Here's the first one. We have a figure here, and it tells us that A, B, C, D, E is the pre-image. So that means that this other figure here is going to be the image, or the second figure. So we have some questions to answer. So we're going to skip number 7. We'll just go to number 8. All right, number 8 says, what type, name and describe the transformation. Well, if we're going from A, B, C, D to this other one, okay, then we're going this way. And what happened was we reflected, so this is going to be a reflection. And we reflected over this y-axis. Over. So that would be the description of this transformation, a reflection over the y-axis. Remember, we think of it as a flip, right? As a flip. Flipped over the y-axis. Alright, next, let's go with number 9. Number 9 talks about what name the image of CD. So CD is part of the pre-image, so we need the part of this other figure, the image. Well, C is here, and D is there. So if I flip it around, I look like I'm H and I. And there we go. Segment HI. Okay. And then we'll do number 11. So we skip 7. We skip 10. We'll do. Name the coordinates of the pre-image of I. So here's I right here. So it looks like if I flip around, D is part of that pre-image. So I'm looking for the coordinates of D. The coordinates of D are 1, 2, 1, 2, 3. 2, 3. Basic transformation problem. Recall that when you transform something, okay, the transformations we've been doing have been isometries. Okay, all those theorems, rotations, reflections, translations, are all isometries, meaning that the lengths here are preserved. It preserves congruence. So this figure is congruent to that figure. Okay, here are our next two problems. So we are going to look at doing some reflections in the coordinate plane. So reflect the points. There's the instructions. Reflect the points. Okay, and I'll use blue for this graph. So we need to take 3, 5 and reflect it in the x-axis. So let's first put 3, 5. 1, 2, 3, 1, 2, 3, 4. There's our n. And we're going to reflect it about the x-axis. So what I'll do is I'll put a dotted line on the x-axis. Now the x-axis is horizontal. So they could also give you this equation for the x-axis. Y equals 0. Y equals 0 is, y is the equation of a horizontal line. And 0, all the y's here have 0. So if we're going to reflect it about the x-axis, remember that we need the same distance above and below this horizontal line. So we're going 1, 2, 3, 4, 5 up. So we got to go 1, 2, 3, 4, 5 down. And here's my n prime. And it's at the point 3, negative 5. Okay. Now, if I move on to this one down here, P, negative 2, 3, reflected in the line x equals negative 3. Well, let's put P on there. Negative 2, 3. There's my P. Okay. And the line x equals negative 3, that's a vertical line right here. 1, 2, 3. Negative 3 over. So there's that line, x equals negative 3. So again, same distance to the right and left. So we're 1 away here, so we need to go 1 over here. Okay, and there is my P prime. And your P prime is going to have coordinates negative 1, 2, 3, 4, negative 4, 3. So again, here the x changed. All right, the x changed. And there's just some basic reflections in the coordinate plane. Okay, our next problem here is again a reflection problem. We're going to reflect this figure, this quadrilateral. So reflect. So again, I'll use blue. And it's all about perpendicular distance. This distance right here, needs to be the same on the top or to the upper right and lower left of this line L. There we go. So there's a point. Same thing here. So we take a measurement perpendicular. We try to estimate there. Same thing here. So this one's pretty far, huh? So this one's might be off my picture a little bit. And then this one, perpendicular distance, perpendicular distance. So we're saying right about there. Okay? And I'll connect the dots as best I can. You'll have a straight edge on the quiz. And there you go. There's the reflection of this pre-image to this new image. All right? And again, perpendicular distance has to be the same. Okay, next problem is one of my favorite problems. The directions say find C on the x-axis to minimize AC plus BC. Okay. All right. So find C on the x-axis to minimize the distance AC plus BC. So we take A and B, and again, remember, this is my new B's. And we take A and plot it at -3, 2, and B is -6, 1, 2, 3, 4, 5, 6, 6, 4. And we're looking for the point C that minimizes this distance. So we assume it has to be closer to A, and it's going to be in between A and B. So what we do is, remember, we reflect a point. So take one of your A's or B's and reflect it over this x-axis. So I'm going to take A. It's 2 above, so let's go 2 below. There's A prime. And then I'll do my best to draw a straight line down from B down to A prime. That's as good as I could do. But you should notice that it's going to go through a nice point, and that point it's going to go through is right here. Okay, at -4. So your C that you're looking for here is -4, 0. And that represents the shortest distance, the point that represents the shortest distance here, from A to C and then back up to B. Okay, next problem says draw the figure. And we're talking about lines of symmetry. So we're going to draw this figure, and we're talking about lines of symmetry. So if I'm looking for a hexagon with exactly 2 lines of symmetry, I think I need to have some congruent sides. Now, if I try to draw a regular hexagon, which means all the sides are congruent, and again, I'll do my best here. That's pretty good. So what's going to happen is I'm going to have several lines of symmetry. I'll have one down the middle. I'll have one this way, cutting it in half. And then I'm also going to have a bunch more here, diagonally. Okay, splits it in half. I have this way, splits it in half. So you have so many if all sides are congruent. You have many lines of symmetry. So if you're looking for a figure that has several lines of symmetry, you want it to be regular. Okay, but we want one that has exactly 2 lines of symmetry. So not all the sides are going to be congruent. Let's take a look at this figure right here. Let's make the top 2 sides congruent, so they're the same length. Let's elongate the sides, the opposite sides, and then let's make these bottom 2 sides the same as the top. There we go. So now look at what I have. I have a line of symmetry down through the middle. There's one. And then I have a line of symmetry through the sides, splitting it in half. But other than that, that's all I have. Okay, if I try to go diagonally through, my left side's not going to equal the right side. Okay, remember, line of symmetry. Left side has to equal the right side. Top has to equal the bottom. So here's my hexagon that has 2 lines of symmetry right here. Okay, with some congruent sides. Okay, so now let's move on to translations. We've done introduction to transformations. We did reflections. Now we're going to talk about translations, which is the third part of your quiz. So here's our coordinate notation. This is coordinate notation. And you might be asked to move an object. You might just be asked to find points. Okay. So the question is, what is the image of 5, 2? Well, the image is the second figure, meaning you're going to be going this way. So you're going to do exactly what this transformation tells you. You're going to take your points 5 and 2, your coordinates, and you're going to do exactly what it says. You're going to add 4 to the x. You're going to subtract 6 from the y. So that'll get you your new points of 9, -4. Okay, so finding an image. Okay. Now let me fix this number 9 because I want, I'll just fix it right here. Okay. So pay attention. We're going to not find the image. We're going to find the pre-image. Okay. We're going to find the pre-image. So now we're saying that this is the final result. What was the pre-image? So now we want to go backwards. Okay. So if we take these points, coordinates, -3 and 4, we have to do the opposite or reverse of what it says. Reverse. So if it says take x and add 4, we're going to subtract 4. If it says take y and subtract 6, we're going to add 6. To go in the reverse order, to get back to the pre-image. And this would give us the coordinates -7, 10. So if you took this point, -7, 10, and did what the coordinate notation says, you would arrive at the point they gave you. So just some basic coordinate notation. Okay, and here's the final problem. It's going to incorporate vectors. So I want to find the vector components of the transformation. Okay, so I want to find the vector components of the transformation. And here in this picture, I'll use blue, we have an arrow going this way. So we have A, B, and we have A prime, B prime. Okay, so my suggestion would be is to take one of your points. Let's do A and A prime. And let's go ahead and draw our vector from A, the initial point, to A prime. And I'll put an arrow right there. Okay, so because we're using this as an example, I'm going to label it as A prime vector, so that we just remember how to label a vector, right? The initial point's first, the terminal point is second, and we have the half ray. So we're going to look for the components. Now remember that the components come in this pointy brackets. We have the horizontal first and the vertical second. So if I'm on this picture, I'm going to go horizontal first to go from A to A prime. That is going to be 1, 2, 3 to the right. That's a +3. 3 to the right plus 3. There's my horizontal component. Then I'm going to move 1, 2 down. -2. There's my vertical component. And here's my vector in component form. 3, -2. Now, if I want to put it in coordinate notation, okay, just to see how so coordinates, how they go back and forth. Remember that in component form, those numbers just go with your x and your y. X +3, y -2. So this would be a way to describe the translation in coordinate notation. So hopefully this helps, and you feel prepared for your quiz on Wednesday. Thanks for watching. Bye.